Hello again. I thought today to finish up this class, it might be a good idea if we just took a few minutes and did a review sheet together. And it looks kind of like a video quiz, but I'm not going to score it as a video quiz. You just turn this into me and I will give you 20 points. Okay? So just make sure you follow along with me. Get this up on your pen tablet and get this up on your pad or your phone, and so that you can watch what we're going to do here and do this with me, and you will be grateful that you did, because you'll get the points and you'll review a lot of useful material that will soon be on the final exam. The sheet that I want you to bring up is called Group Work Cs Rev. What Cs Rev stands for is Course Review. So we're going to take a look at these questions. I'm going to give you time to answer each one as we go, and then you can put the correct answer in if you happen to make a mistake. So fill in the blank preceding each problem number with the letter that correctly answers the question. You can assume there's only one correct answer per question. Well, remember, I wrote this thing, so that's not necessarily true, but I will hope it is. Okay, so here we go. Question 1. Remember, this is GWCS Review. Hopefully you have this ready to go on your pen tablet, and away we go. Which decimal shown cannot be expressed as a fraction? Well, the correct choice is C, and let's see why. 0.625 bar converts to the fraction 3 and 625 9/99ths by the Kelly's-Cheater method. So therefore, that's a fraction. Choice B here, 0.388 is 388 thousandths. So that is a fraction. What is this thing? Well, remember the Kelly arrow refers to what? The fact that this decimal goes on forever, never repeats, never terminates. Therefore, it's irrational, and you know that irrational numbers cannot be written as fractions. All right, and of course, -7 divided by 15 would be the fraction -7 over 15, and of course that's obviously a fraction, so that answers that question. So let's go on to question number 2. The ancient Greek mathematicians felt that every number one could think of could be expressed as a rational number. Which of these numbers definitely shows that it is not capable of being rational? Well, to be rational, remember, it has to be a fraction, although whole numbers and integers are also rational numbers because they can be expressed as the quotient of two integers. Look at choice B. That is a repeating decimal. Using the Kelly's-Cheater method, you would put 95825 over how many nines? 5 of them, right? So therefore, choice B, all right, is a rational number. Look at C. What is the square root of 144? Well, there are actually two answers. It can be 12, because 12 times 12 is 144, or -12, right? Because -12 times -12 is also 144, so therefore that's rational. 2/30ths? Choice D, obviously a fraction, obviously rational. And 0.875 is 875 thousandths. Obviously, it's rational. Look at A, though. Choice A, which is the correct answer, all right, cannot be expressed as a fraction. It is an irrational number. It goes on forever as a decimal. It never repeats, and it never terminates. Let's go on to number 3. Which correctly shows an irrational number made up of only 3s and 8s? Well, I think you can see that both of the number parts written out are exactly the same, right? A 3, 8, 2 3s and an 8, 3 3s and an 8, 4 3s and an 8. The first one here shows a dot, dot, dot notation. The second one shows an arrow. What does dot, dot, dot mean? Continues in the same pattern, right? What does an arrow mean? An arrow means what? It goes on forever. It's all over the place. It cannot show a pattern, in other words. So your correct choice is choice A. A lot of people on the last test, when asked to make an irrational number for me, made one, but they forgot to put the 3 dots after the pattern they created. When you create a growing pattern, you must show 3 dots after it to show that the pattern continues to increase. The reason A is okay is it would continue just using 3s and 8s, even though the pattern would grow. This indicates by the Kellyism that this decimal is all over the place. It's not just 3s and 8s. It could be 1s, 3s, 7s, 9s, 4s, 6s. It's all over the place. That's why choice B is not correct. So in case you're having any trouble with that, you can see that is why the correct answer is A. Let's go on. Given these 3 Fibonacci numbers, which number should be next in the Fibonacci sequence? See if you can put down what the answer would be. Well, if you recall, the Fibonacci sequence is generated by taking the previous 2 Fibonacci numbers and adding them together to get the next one, right? So what I have to add here is 55 and 89. If I add 55 and 89, you'll notice I get 144, which is choice D. So the correct answer here should be D. Which polyhedron is not a Platonic solid? Now, all these names here, cube, pyramid, tetrahedron, and icosahedron, are all names of polyhedrons. But they're not all Platonic solids, okay? Remember, in order to be a Platonic solid, all the faces have to be exactly identical. In a typical pyramid, its bottom or base could be a square, it could be a pentagon, it could be any other shape. I haven't said what type of base it would have to have. And of course, all the faces would have to be triangles. So a tetrahedron is actually a type of pyramid, all right? But a tetrahedron has all of its faces exactly identical. So the correct answer here, which one is not a Platonic solid, would be just a general pyramid. So that is choice B. So not all pyramids are Platonic solids. Only the tetrahedron is. Okay, a paper bag contains 3 red marbles and 5 blue. So I'm going to put over here 3 red, 5 blue. That's a total of what? 8 total marbles in the bag. What is the probability of picking a red marble out of the bag in one single draw? Well, I'm sure you've had time to answer it. You know there are 3 red marbles in the bag out of a total of 8 marbles that are located in the bag. Therefore, there is a 3/8 probability that you could pick a red marble, which of course is choice D. All right, let's go on. Which of these expressions is equivalent to 7 mod 13? Well, let's see. What I'm going to have to do for each of these expressions is add the numbers together and then divide them by the mod number 13. If I take 12 and 27 and add them together, I get 39. 39 divided by 13 goes exactly 3 times with no remainder, right? Therefore, it can't be 12 plus 27. Let's try 15 and 6. Well, 15 and 6 adds up to what? 21, right? So 21 divided by 13 goes once with a remainder of 8. We want a remainder of what? 7. No good. All right, let me get rid of that. Okay, let's go to our next one. 13 plus 8. 13 plus 8 plus 5. Well, let's see. 13, 8, and 5 add up to 26, right? Is 26 going to be the same thing as 7 mod 13? Well, if I take 13 into 26, it goes exactly twice with no remainder. Therefore, that's not 7, is it? So that doesn't work. All right, so let's go on. We've got one more to check. And of course, you know that's got to be the right answer because it's the only answer left, correct? So let's try it and see. All right, so if I take 12 and 8 and add them together, that's 20. 20 divided by the mod number 13 goes once with a remainder of 7. And that's the animal I want. So therefore, the correct answer is, of course, D. The formula A equals 1/2 H times the quantity B1 plus B2 is the correct area formula for which of these polygons? Well, I'm sure you recall that it is the trapezoid, which is choice A. Remember, in a trapezoid, you have 2 bases, the top and bottom. Let me sketch one over here very quickly. It'll be a lousy one, but let me put it down here. Here's a trapezoid. B1 and B2 are the top and bottom bases, if you recall. The height is the dotted distance here, perpendicular to those bases. And when you do 1/2 H B1 plus B2, H times B1 plus B, the quantity B1 plus B2, gives you 2 of the trapezoids. We only want half of that. So that's why the 1/2 is in there. Okay, 9. Which number is the decimal equivalent of 18 and 2/3? Well, we don't really need to worry about the 18 too much, do we? Because you know what's going to be in the answer. How do you write 2/3 correctly as a repeating decimal? Well, I'm certain that most of you are aware that the correct answer would be answer B. 0.66666 forever, all right, as the bar notation shows, is what 2/3 divides out to be. 0.6 with the bar or the arrow after it, my Kellyism says what? That is a decimal that goes on forever, but it's all over the place with all different kinds of numbers. So it can't be D. And C, all right, and A don't work because they only start what the answer is, or 2/3. They don't show that it repeats to infinity. So choice B is the correct one. 10. Which answer is the correct prime factorization for 60? Now, if I tell you that all four answers, if you multiply them together, do give you 60, that can help you decide which one is the correct prime factorization. Remember, the prime factorization of 60 must be the product of all prime numbers. If you look at, for example, choice D, 20 isn't a prime number. It couldn't be choice D. If you look at choice C, it can't be that because 10 is not a prime number. If you look at choice B, both 6 and 10 aren't prime numbers. So that can't be the correct prime factorization. But you can see 2 times 2 times 3 times 5 is all prime numbers. And if you multiply them, you do get 60. So the correct answer here is A. Okay, which piece does not correctly describe the behavior of a rational number? Well, let's look at A. It repeats or terminates. That is a correct description of the behavior of a rational number. The division of two integers A over B, B cannot be equal to 0. That's correct when describing a rational number. It goes on forever and can repeat. I think I made a mistake here. C is supposed to say goes on forever, cannot repeat, right? It cannot repeat. Now, if I say that, that is not correctly describing the behavior of a rational number. The correct choice here would be C. Kind of screwed that up, didn't I? Oh well, what you gonna do? All right, let's go on. 12. If the value of 2 to the 18th power is 262,144, if that is a correct statement, then how many times must you fold an extremely large piece of paper for the folded paper's height to reach a thickness of 262,144 sheets of paper? Well, it can be determined, so D isn't right. Okay. It isn't 262,144. Okay. Now you wouldn't have to fold it that many times to get 262,144 sheets. 36 isn't right. If you double 2 and 18, you get 36. I just put that in there to try to mess you up. The correct answer is C. Remember, the power of 2 that is up here is your number of folds. Since it was an 18, right? Since it was an 18, you know you would need to fold the piece of paper 18 times. Okay, let's continue. If Fibonacci number 11 in its table is 89, Luca number 6 is 11, and Luca 12 is 199, what is the value of 3 times Fibonacci number 11 decreased by 2 times Luca number 6, but first you have to square it. So let's plug this in. 3 times Fibonacci number 11, which is 89, decreased by 2 times Luca 6, 11, and that 11 must be squared. You do not square the subscript. You square the actual Luca number. All right, if you do 3 times 89, I believe you will get 267. If you square 11, it's 121. 121 doubled is 242. So if you subtract those two, what is the correct answer? Well, I believe you can see if you subtracted them, the correct answer would be 25, which is choice D. Now, 13 students are seated in a classroom, and we know that each were born in the same exact year. How can we be certain that at least two people, or at least two of the students, were born in the same month of that year? Which answer is correct? A, no way to tell? Or B, PHP, baby, duplication must occur. There are more students than there are months to pick from. Because there are more students than there are numbers to pick from, that guarantees us that duplication must occur. And that's by the pigeonhole principle, PHP, baby, which of course is letter B. If a bag contains 5 blue marbles, 5 blue, I'll put that over here, and 7 green, how many marbles must be drawn out of the bag to guarantee that 2 marbles of the same color have been drawn? Now, isn't it possible that if I drew 2 marbles out of the bag and they both came out, for example, green, I'd be done. I would have done it in 2 draws. But what if I had drawn a green marble first and a blue marble second? I've not satisfied the conditions of the problem, correct? I'd have to draw 1 more marble. And if I draw 1 more marble, you know 2 of them have to be the same color. So the correct answer for this is choice D, which is 3. (16) In a golden triangle, which of course is a right triangle, which statement must be true? The hypotenuse is twice the length of the shorter leg, or the longer leg is twice the length of the shorter leg? Well, I'm sure you realize that the correct answer to this problem is B. The legs are compared in such a manner that one is twice the length of the other. So it is choice B. If the largest square that can be placed in and positioned to the far right in a golden rectangle is sucked out of that rectangle, the small remaining rectangle left behind is what shape? Is it a square? Is it not a smaller golden rectangle? Or is it a smaller golden rectangle? Well, I believe you will recall that the correct answer for this is C. When you suck the largest square out of a golden rectangle, okay, that is positioned either to the far right or to the far left, there is a smaller rectangle left over. And we have shown that that smaller rectangle is indeed a golden rectangle. If you have a golden rectangle constructed in such a manner that its length is on the bottom and its width is its height, and you have drawn a large square either to the far right in the golden rectangle or to the far left in the golden rectangle, when you suck out that square from either end, the figure left over is a smaller rectangle. And if you recall, it is a golden rectangle, all right? So, correct answer is C. 18. If you have 3 line segments known to be golden sections, then A, if you divide the length of the longest segment by the shortest segment, you will get phi. B, if you divide the length of the middle length segment by the shortest segment, you will get phi, the golden ratio. Or if you add the 2 shorter lengths of the segments together, you get phi. Well, the correct answer is B. The middle length segment and the shortest segment divided by the shortest segment will indeed give you phi. 19. You come up with or find a counterexample to do what? To prove a mathematical statement is always true. To prove that 2 mathematical statements are exactly the same. Or C, disprove a mathematical statement. In other words, show that it is not always true. A counterexample is used to disprove a statement and to show that it is not always true. So this is choice C. Finally, our last question. 20. In a right triangle, the area of it is equal to BH, the base times the height. The area is equal to pi r squared. Or C, a squared plus b squared, the 2 legs, are equal to c squared, the square of the hypotenuse. Of course, it is choice C. The other 2 area formulas are incorrect. Okay, I want to thank you for taking the time to go through this short review with me today. Your homework assignment will be as is stated in the email I sent you. So refer to that, okay, and you will know what you have to finish for this class today, okay? So, with no further ado, I will say so long, and we'll see you again soon in our next class.